Hello and welcome. Today we're going to look at open data, specifically the Open Images dataset. It's one of the largest image datasets out there, so I'm really excited to check that out. Let's get started. Okay, for some reason, it's dark right now, so I'm going to switch over to this. All right. Hello and welcome to Adventures with Yufeng, where we explore new and interesting concepts live from my webcam to your screen. My name is Yufeng Guo, and today I am excited to be looking at the Open Images dataset. It's one of the biggest image datasets out there, and we're going to try to build something kind of analogous to a simulation of live streaming data sets, right? So a lot of times we talk about building data sets for machine learning by collecting them from the world around us. And oftentimes this data set might be something that is streaming in or coming in chunks piecemeal at a time. And over the course of the data coming in, you want to continuously train, update, evaluate, validate, and deploy your models to production. And so that's a big task. We're obviously not going to cover all of that today in 1 hour. And what we're going to start with, though, is, as always, the data. Let's take a look at the Open Images dataset and see where we can go from there, right? We'll look at the dataset, get our hands around it. At a cursory glance, we're talking, it's on the order of hundreds of gigabytes compressed. And so, uncompressed, it's much, much larger. And as always, we're live streaming. So if you're watching this live, be sure to say hello in the live chat, either to my right here or down below the video. We see Rajan Patel is coming in from London. Hi, Rajan, and happy Easter to you as well. And today it's Monday, April 13th, and well, I guess it's better than it being Friday, April 13th, right? It's not Friday the 13th. It is a Monday. And with that said, let's get right into it. And remember, you can always ask questions in the live stream, and I will be happy to address them as they come up. So let me set this up, get us to our coding view, and let's take a look at the Open Images dataset first and foremost. What is it, right? this is arguably one of the largest data sets out there for image data. This one is, we're up to V6 now. It was just released February 2020. I'm going to tweak the camera a little. Risky maneuver here. Ooh, okay. They just released this latest version in February of 2020. For a long time, it was V5. And this data set has millions of images, right? How many millions? About 9 million images. So soon they'll be hitting that next order of magnitude. When they get to 10 million, they'll get to the however many digits that is, the 8-digit club. And specifically, what we're interested in is the 16 million bounding boxes that covers 600 object classes across their 1.9 million images of those images, right? So it's a subset, but even this subset is still the largest existing data set with object location annotations. So this is, it's got it all. And I'm excited to see what we can do with it. And we also see that it extends beyond just like single labels. A lot of these images have many boxes. We see here the images are diverse and contain complex scenes with several objects in them, 8.3 per image on average. And so this, that goes into a lot of the details around objects per image, the percentage of the image area that's covered by a given box. And as always, it's important to cite your work. So this is, of course, the Open Images dataset v6. And I guess I will cite them by way of pointing at them and saying it's this one. The citations on these papers are kind of what you should use if you end up publishing any work that uses this dataset. Even though this article is about the Open Images dataset v4, you should also use this same citation for v5 and v6 as well. And we have greetings from Charlie and an anonymous user from New York. Hello to New York. Hope you are staying dry. Right now, New York is getting pummeled with rain, and there's a flood warning across the 5 boroughs. So let's see. And then the other citations here are about if you use instance segmentations. So beyond bounding boxes, this data set also contains even more awesome stuff. Image segmentations are where you have a kind of delineated portions of the image saying like this exact outline is a certain object. And so that can also be extremely, extremely useful. Onwards to data organization. It's very important to understand how these large data sets are structured so that we can be well informed as we go into the non-trivial task of kind of getting our hands on this data set, because it is quite large and it's literally not really possible for us to put it on most kind of conventional local systems, right? Local desktop systems, laptop systems. I looked at that and took one look at it and I was like, well, I know none of these images can ever touch my laptop because it's just too big. Downloading this would be just not realistic. And so we'll go down to the bounding boxes section here, and we see, again, these 600 object classes, and we have a split of 1.7 million training images holding 14.6 million boxes, along with a couple tens of thousands or 125,000 in the case of test images and their corresponding box counts as well across these 600 classes. And so, of course, we can choose to do a subset of this, and that's something that will be interesting to look at is, instead of doing 600 classes, what if we chose some meaningful subset and then selected our images accordingly that way? And the challenges that come with dealing with such a large data set and trying to find the right images, because it's not as simple as just slicing a pandas data frame oftentimes, because it's just much bigger than usual. And then it talks about object cementations and the other kind of pieces of it. I want to also call attention to this hierarchy. So there's a hierarchy for these 600 classes of bounding boxes. They're not just a big list of 600, though you can get that list obviously. But this hierarchy is particularly interesting to me in how it was kind of visualized. Right, this is a pretty neat visualization. So it starts from the middle, an entity, just a generic something or another, and then it breaks down to things like animals and mammals and carnivores and bears, and then you have different kinds of bears and lots of other things here, everything from more animals. We have tools and sports equipment, kitchenware, furniture. And so the hope is that everything under the sun, or even I'm sure space is in here too. So beyond just things under the sun might be included in this data set. That's actually a good point. Is there anything here about like stars? Where is it? Oh, it says, what does it say? Wow, it's two, but it looks like it's under marine invertebrates. Oh, probably starfish. Not star. What about planet? Anything about a planet or space? The final frontier. Galaxy. All right, so it looks like the astronomers in the audience are getting a little bit left out. So fair warning, I suppose. Don't use this for space. And let's see. Yeah, with that, let's move on over to the download tab, right? The task before us of how do we actually get this data set into our hands beyond just browsing about it on the web. And we can see there's a lot of different options, and they've made a really nice kind of site here for us to download from. So there's 2 download options. I'm going to open them each in new tabs. And we can see that this is for downloading the image data set specifically. And these are the boxes that we're interested in. And there's a train box. So if you can see in the lower right-hand corner here, when I mouse over each of these links, down below there's kind of the URL. And you can see they're just CSV files that are just hosted. The only concern I have, and it's a little bit funny, and I suppose, I would be interested in knowing more about what changed from V5 to V6, because when you look at this, the train CSV is, if you look at the URL, I'll just copy the link out. This way you all can see it properly. So this URL is openimages/v6/oidv6. That's open images dataset v6 train annotations. Seems very reasonable. Now let's go over to validation, and I'll copy that link address as well. Why is it that this validation data set then is v5? Notice that. So I was mousing over that and I was thinking that's a little bit odd, and I would be curious to see if the corresponding v6 URLs exist, and if they do, whether we shouldn't be using those instead. So let's play with that real quick, just as a curiosity, because that's what this is all about, exploring options. So it either doesn't exist, or it specifically says I don't have. This suggests that it exists. It's not a does not exist. It's an access denied error, and I bet this one might yield a similar thing. Well, let me try V5 first, right? V5, this is where the test annotations. Will it let me do the download? It seems like it will load. And if I do the same but change that to a 6 and press enter, we have access denied. So it's unclear at the outset whether or not it exists or not. Let's try something that definitely doesn't exist. Instead of this file being .csv, let's call it CSV ABC. Right? I'm going to make up a thing. Okay, so it has the same error. So this suggests that it's not necessarily that it exists and I don't have access. It's more that it either doesn't have it doesn't exist, or I don't have access. It's not immediately clear. So it looks like we can't bank on there being an error here, which is good, generally speaking. I suspect that it's because the did we lose our tab? Okay. I suspect it's because in V6 what changed was the training data. They expanded the training data set, but validation and test remained the same. And we kind of see that reflected potentially here as I mouse over some of these other URLs. If they'll show up, that'd be great. So relationships V6 are updated to V6. Image labels are V5 training, V5 validation, and V5 test. That's interesting. So it suggests that perhaps the images haven't even changed. Like these image labels have not changed. So that means that maybe the only thing that changed were additional boxes were added, which really tells us something about the kind of intended use here, that it really was meant for bounding boxes, right? That's what they're continuing to grow. And we can also click V5 and see kind of the changes here. You are viewing V5, V6 is the latest version. So this says it's 1,743,042 training images. Okay, it's the same number of training images. It's the same number of validation and the same number of test images. So the images haven't changed. Have the number of boxes changed? Perhaps, but we don't know. Okay. The task here is not to do box counting. So let's work on actually getting our data, right? Let's talk a little bit about that. What does it look like? So our options here are, we have the CV, Computer Vision, I believe Computer Vision Data Foundation. They posted this GitHub page that describes how you can download the images with bounding box annotations. And Figure 8 also has a kind of hosted version of this. I'm going to choose in this particular case to go with the Figure 8 option just because they have direct download links to the zips, and it hopefully works. Unfortunately, I have failed. So I tried this this first one to see what would happen, and it started downloading. It spent about 16 minutes and pulled down the 52 gigabytes in this first training partition. So what they've done is they've partitioned the training files into 9 separate zip files, each just short of 60 gigabytes, except for the last one, which is 42. And I am terrible at using curl, apparently, and did not manage to write the file out or something. Let me just confirm curl is, I'm pretty sure this is how curl works. Curl command, how to use curl. Because it should just be the URL and then -o. So let's see, put a URL, options. I'm looking for the -o option, right? If you want a progress meter, you need to redirect it to a file. I wonder if it has something more to do with the way I was, like where I was writing to, or the permissions I had in writing it, or maybe my computer went to sleep. That's always possible. Okay, let's look at this again and see if we can't. See, I wish we could just directly access it, but the trouble is then it becomes a problem of who pays for egress. Someone has to get the data out. Let's try a smaller file. So they have some smaller ones here. This one is the test images, and then we have the validation images, which are only 51 or 5.1 meg. Oh, it's the CSV. Okay, yeah, let's go with that. So the validation data set is 12 gigs. The test data set is 36 gigs. So we use the validation data set as our test run because it's the smallest thing we've got. These are images. It's zipped up. This is all the bounding box annotations. We can preview that here. It's a pretty wide CSV file. And then we have the validation images, which also get a CSV file because you want to be able to link the URL of the image to the image name. And hypothetically, we could just get these CSVs and then grab the images manually if we had to via a script. So that is a potential thing. So let's check this out. Let's copy this. And again, I'd like to use a text box to kind of manipulate my commands, get them all set up. And so we're going to do this -o, and we want this kind of file name right here. And I'm going to copy this command and put it back in our Jupyter notebook. Let's see, I have this file that was from earlier. Oh, it seems like it worked. Why does it say curl failed writing the body then? Because that, for all intents and purposes, is 53 gigs. Yeah, so that was one of my, that's also a nice trick is ls-h. The h argument makes it human readable. And so I've turned this big long string, which I would have had to kind of squint at and figure out how many sets of 3 numbers. Now it's just 53G. It's very clear. A little bit concerned that the file is red. I hope it's just because it's a zip file and for some reason we've decided to visualize it with a red image. I'm going to grab this next one, this CSV. Let's see how this one does. So again, we have this failed writing body error, and then this doesn't equal that problem. I wonder if that might just be, again, this curl issue. Am I specifying something wrong and it's not really relevant to our download? Curl something something, if it doesn't work in a pipeline. For me it works, need buffer. This happens when a pipe program closes the read pipe before the previous program. Is this even the error I'm looking for? Failed writing body. Failed writing body. Yeah, that is the situation. I'm hoping that it says something like, it doesn't matter. It's a matter of how curl manages the buffer. Okay, it looks like it's just for buffer management. The destination directory does not exist, e.g. if you have, and that entire path. Okay, maybe if we, curl can do this instead of using the dash open, if you just pipe it straight into the file. So not using the pipe and instead using it. All right, and in this adventure, through scrolling through Stack Overflow, I think we've concluded that everything is fine. Ooh, maybe not. 4 kilobytes. That is not, was that really the size of that CSV file? Yeah, that was supposed to be 5 megabytes. So this URL, if I click on it, it doesn't open fully. Let's look at this. Okay, so cat validation images.csv. Oh, it is the right thing. What if I do a word count on that? 32. So it only got the first 32 rows. Did I do only the preview link? Is that why? I didn't think I did, but it's always possible. No, this is the preview. This is the whole thing. If I copy, what if I say save link as, and I just save validation images that way? Will that open? And how big is it? It's gonna try to open it with Apple's Sheets numbers tool. That might not be what we want either. So let's go to downloads. It's 5 megabytes. Ah, interesting. So it does think that it's 5 megabytes. And when I preview it, I'm gonna cancel this numbers loading. Not now. So that works. Huh. That's not a great sign. Am I running out of local disk space? Yes, that is a good question. So it's not impossible, right? Like, you know, I did just get a biggish, 53 gigabyte thing down. If we do, what is it? LS block. So that's the size of our disk partitions. This one that we're in, the main boot disk, is 1,000 gigs. It's 1 terabyte. So 53 gigs. I would be very disappointed, shall we say, if that didn't work. Now, it's possible that it's trying to write this 53 gigs into the SD1 partition, which would be less than great. Now comes the question of, does anybody on this live stream know how to write the files to the correct partition of a Linux file system? Did not expect to be going through this today. I suspect that's why this wasn't worked correctly either. How can we test this? We can, firstly, we can try downloading that again, right? What if we just like curl google.com, right? Oh, that's not Google. Spell Google right. The document has moved. That's good. And if I output it to test.html, it still says failed writing body. That is suspicious, and it's 0. Huh. And then if I tried recurling that validation images CSV, but I'll call it validations images 2, it also crashes out. So yeah, I am inclined to agree with you that I may have run out of disk space, especially given this very suspicious notion that it says it's 58.6 gigabytes. And as we can see here, it's not 58.6 in any sense of the word, right? This is at best 56 billion bytes. And if we do ls-lh, then it's 53 gigabytes when you do it via base 2. So df-h, thank you. You are a godsend. Now the question becomes, how do we make sure we get to the right thing? 99 gigs out of 95 gigs, or 99 gig size, 95 gigs use, available 0. So I am on the wrong partition. I'm definitely going to save this command. Thank you for the save. That was huge. Check disk size remaining. All right. And now comes the real problem of, let's see, how do we, let's say in Linux, yeah, use is 100%. So let's see, Linux, write to, I don't know, a different partition. This is really kind of going to uncharted territory. I typically don't end up writing stuff to local disks. If I had it my way, I would just have enough room to download and then re-upload just as soon as possible to a cloud-based storage system that's like more distributed. But really, I want to write to, how about GCE? So we can resize persistent disks, but the problem is I'm on the boot partition right now. How do we find, oh, is it under like mount or something? ls root, ls-l root, and then the other, are they, man, that is some deep memory. I don't know how I remember this. I may not have yet. Let's hold our breath. Okay, that's not what I thought it was. Okay, so where are the other partitions? Right, so there's all these instructions about managing storage and adding these disks, but I wish there was a piece of instructional advice on the actual access and use of it, right? So let's take a look at this guide. Make sure our spacing is good. I'm going to zoom back out just temporarily so we can see this table. We can format and mount a local SSD device. That should be similar to formatting and mounting a non-local SSD. Oh, this looks familiar. This is what we had before. Okay, so if that one worked, surely a similar guide exists for adding or rezoning, resizing the file system and partitions on a zonal persistent disk, formatting and mounting a zonal permission disk. Yes, that persistent disk. This is what we're looking for. I thought of doing this. I wanted to create a separate persistent disk because in our very first episode of this series, I had a chance to chat with Brian Dorsey, and he kind of illuminated me to the point that persistent disks in the cloud are not the way we think of a disk drive on a machine. They're actually just distributed little bits all over lots of different machines, and they're just tied together in software. And because of that, it allows it to both read and write at phenomenal speeds, and it means you can connect multiple instances to the same persistent disk at once. And so that means what I wanted to do was write to one giant persistent disk and load up this with this data set, and then I can connect to it from any VM of my choice as I destroy and create them. The problem is I did not mount it properly. Like I attached it to the VM like we saw it here, ls block, that I mounted this drive that's 3.9 terabytes. That was on purpose. I did that beforehand, but I was like, I wonder how I actually get to it. So this is the price I pay. So we see here in this example, SDB is the device ID for the new zonal persistent disk, and that's exactly what we're seeing as well. We have this libdb, and in fact, I have an SSH window here to the same ls block to the same drive. So I'm going to put this side by side so that we can kind of work and check our output as we go along. Okay, so we have this. And then we want to format disk. You can use any file size format you need. We'd recommend use extended 4 file system with our partition table. This allows you to resize the file system without having to modify disk partitions. Sounds good to me. Format the disk using make file system. This command deletes all data sets from the specified disk. Make sure you specify the device disk correctly. Yes. Use the recommended formatting options in the -e flag. It is not necessary to reserve space for root on this secondary disk, so specify -m0 to use all available disk space. So this is our command. I'm going to copy it, where device ID is the device ID of the zonal persistent disk that you are formatting. In this example, specify SDB to format the entire disk. Okay, so that's the same as ours, but that is an interesting note. As always, I'm going to paste it into here to check it. We got sudo make fs extended for -m0-e lazy iterable init 0 and dev/sdb. Okay, very important to get that right, because if we type sda, that's the other disk. then what we want to do, let's run this. Should I press enter? Or did it already? I might have to press enter. Enter? All right, there it goes. There it's going, and it's writing, and we're going to read the next instruction here. Create a directory that serves as the mount point for the new disk. You can use any directory you like. The following creates a directory under mount/disk. Okay, so I wasn't completely off of my rockers when I thought it should be under MNT. And so we're going to make a directory. We're going to mount the directory at which to mount your zonal persistent disk. So we'll just call this maybe disk open or something like that. Disks / how about open images. And this is still working away. It's 14,000 out of 32,000. Okay, so it's almost done. What's so nice though is that unlike when you're formatting a local computer, this is happening on a different machine out there. It happens to be in US East 1-C is the zone it's in. And so that means I'm free to kind of look at this and not have things be bogged down. Whereas when I think back to olden times when you'd have to like partition your disk and format it to install like parallel dual boot systems and things like that, you would be kind of like nervous to be doing anything else. And now we got to use mount to mount that disk and enable the discard option. Why? What is this discard option? Where device ID is SDB and mount directory is the directory in which to mount your persistent disk. So that's all the same as what we had before. So dev/SDB, and we're going to call this open images. It's almost done. And then we got to configure read and write permissions on the device. Wow, so this is like serious. All users read and write. Yeah, seems to be fine. What could go wrong? Everybody can write to it. Where mount directory, optionally you can add the zonal persistent disk to the etc. FS tab, file system tab, so the device automatically mounts again when the instance restarts. Doesn't seem like the worst idea in the world. All of this. Okay, so this is something that I might go through perhaps afterwards, since we're not going to be restarting our instance, at least not anytime soon. Let's go on to the next command. What did we just run? We just ran make file system. So now we're going to mount it. Make dir. Okay, so this is we're just making a folder in mount disks open images. Now this command actually does the mounting. Got it. And then once it's mounted, oh, I didn't change this. Gotta be careful. Okay, so this is now mounted. I'm sure I could have used command line or environment variables there, but typing it manually always feels safer. So this means if I now go to, well, does it say anything about this? Or do I just need to remember to go to mount every time I want to mount disks, open images, and we'll use that command that Rajan recommended. Will it say anything about, I want to look at this particular disk specifically. 89 megs used already. That's what I get for not having anything there yet, but hey, there's a lost and found. What did I lose? I lost nothing, or I can't see what has been lost. Nothing. Okay. All right, so let's go here then. I'll make a note of that. So cd into that, and now all the old downloads that we did are kind of useless, right? Because it didn't finish. And again, this time we'll do it slowly, test it. We'll test by using this validation download piece first and foremost. And so let's see, images, CSV. This is 5 megs, just 5 megs. If we can't download 5 megabytes, what are we doing, right? So this better work. This is like the troubleshooting approach where you just gotta believe. Curl this whole thing -o. Oh, I already did all that. That's right above here. Validation images.csv. All right. Rajan is confident that it should work now. All right, so that finished without any errors, and we see that it's here. We have validation dot CSV, and it is indeed ls-lh 5.2 megabytes, just as gonna be close enough, 5.1, 5.2. And then we can get the bounding boxes for the validation data set, which we might have. Oh, this is train. This is. All right, I might make a little script that just wraps it in curl and grabs the last name of this file. I also wonder if it would do that by default if I just put -o and left it blank. Try that next time. Okay, so that downloaded okay. This is a 12 gigabyte validation set. So curl this whole thing. If I just say -o and leave it blank, oh, this is 12 gigs though. I really don't want the file to like spew out. So I'll just do this for the time being. Put this in here. Now, because it's kind of a persistent disk that's distributed, right? It's not actually one disk. No, it's not constantly writing to sequential blocks of data within one hard drive. What I can do, I think, is create multiple downloads at the same time by pausing this process, pushing it to the background, BG. So I did Control Z and then I typed BG. And now while this 12 gigabyte download happens, I can go up and grab all these training data sets as well. These are smaller than 12 gigabytes, so we should be able to do them fairly quickly. This is train annotations bounding box. So that's this one, 2.2 gigabytes. We'll see how that goes. So you'll notice that this is still typing over it. So when I press enter, you see it does that. So when I paste, it's going to be a mess, and you just kind of have to believe it. And I'm going to press enter, and it's going to do its thing. And then really, I should probably make a separate tab, use some kind of tmuxer thing. So I'm going to Control Z that, push that to the background as well. I just don't remember how to use tmux off the top of my head. I usually use a manager called Byobu, which is a wrapper around tmux, but I can start a second SSH session. So that is the poor man's way of getting tabs, because I don't think hitting Command T here is going to do any good. Yeah, it just opens a new tab in our Chrome window. What's going on here? Let's see. This is proceeding, and what we can do now is take a peek at it via. We're going to CD into our mounted drive disk, and we have the various files that we've been working on. Validation.zip, I believe, is something that is still in progress, and potentially a lot of these are still in progress. So I'm going to type that twice, and we can see that already validation.zip has grown. Well, let's do the -h thing again. Grown by, let's wait a little bit and press enter again. Let me make this bigger so we can kind of monitor the progress of things here. Annotations bounding box seems to have completed. Our first download of the 24 megabyte bounding box annotations is completed. Of course, our image, these are done. So we're only just waiting on validation.zip. So I feel comfortable continuing onwards. Let's see. We've got our training annotations. We got our validation annotations, validation images, and validation actual images. So the validation images.csv again is a CSV listing out the URLs and image IDs, whereas validation.zip is the actual physical images themselves. And that's supposed to be 12 gigs if I recall correctly. Yeah, yes, 12 gigabytes. Then under train, the big one, right? We already did the 2.2 training annotations. We need to get the training images list. That's only 200 megs. That's nothing in our, the disk size that we're working with now. And let's see, bounding box annotation. Did I type this twice? This is the trouble thing with having giant images. Validation images, validation annotations. Okay, so this is all validation. Organization is key, they said. Training annotations, and this is the trainable images, and that's this file name. -o, And we'll just grab it here because it should be a quick one. This one they both just finished. That's so funny. Oh no, they haven't. It's up here. All right, no, they are both finished. So we can see here. It's still red. That is slightly concerning, but there were no errors. Before we download the big one, then let's try to unzip it. Unzip validation.zip. It would be really great if we knew the folder structure, if any. Like if it was going to be one giant thing, I would move this into a folder. Let's do that. Make dir validation images, move validation.zip into validation images. And we're going to go into, oh, did I call that validation images? Validation images? Oh, I see what happened. I typed validation, then somehow it auto-completed weird, so we've actually renamed this, the original zip file to be that. No undo in Linux, so you just gotta fix it yourself. Let's move validation.zip into validation images / So then we have what we're expecting. Now let's go into validation images and we have our thing. Now we can unzip validation.zip, and I wish I'd suppressed output, but that's okay. We'll just let that fly a bit. So far, so good. And while that's inflating, we can go into our other window and start downloading the, I think we already downloaded train images boxable. Train images boxable, yeah. So we have train. I'm going to change this file name later so it starts with train, since that's kind of the style that we're using here. Meanwhile, I will make a new folder, train images, just to stay with the style that we're working with. And then we have to download this 58 gigabyte file, copy link. Oh, I already did this part. So this could be a starting point. Now, what I was thinking in terms of what to do with all of this, right? Like once we get our hands on it, what are we trying to build? What I'd like to build is something where we can take a slice of the data. Let's say in this case, the first piece, which they've called here train 00, right? We'll take that first 58 gigs, which still feels like a lot of it, and we'll call that our kind of original training data set. So that would be analogous to when you're trying to build a system and you have some data set already pre-existing, some historical data. And so we take that and we try to run it to train a model. And once we have that model, we can then we want to build additionally some system where I can basically on demand, because it's a simulate clicking some new data coming in, and that would be this other data, right? Train 1, train 2, and it wouldn't have to be all of it, right? 59 gigs of images is substantial, and so we can have it, you can basically ask for give me another 1,000 images, give me another 10,000 images. And so then those label data come in, and the idea would have it then feed into some kind of system, some machinery essentially, that can combine that in with the existing data set, update our training, do the model fine-tuning, run evaluations, and then deploy it all. And so we have this end-to-end system that truly emulates what it's like to work with kind of a living, breathing data machine, right? So we've got our all of our images coming in here. Let me do an ls-l and pipe it into a word count to get the number of files. This might take a second. That's good. Why is it? Because it's too big? Oh, it did make a folder. Look at that. Okay, so validation made a folder. That's good to know. So let's move that out, I guess. This feels a little awkward. At least it's small enough, right? It's not the 58 gig version. Validation. All the other ones are gonna have something inside them as well, then I assume. I kind of want to leave it this way then, because the other ones will be train images, and then we'll have subdirectories of train 1, train 2, train 3, and then the folder structure would match. Yeah. So meanwhile, let's grab our test data set. We have test annotations, test images. I'm going to download, not copy link address. So we get that. So this is train. Validation and test. And this would be a good one to test out our theory about curl. Who would have thought this was just a game about curl? Okay, so it does require something. For next time, unzip-l will list the content without extraction. Yes, thank you. Very good. Things to look up before I just run commands blindly, right? How? Because like these are all should be pretty straightforward. I don't know why is it -l, I wonder. Okay, we're gonna download. Oh, I'm downloading it into validation images by accident. Let me move this out. Test images, move to the up directory. Great. And then I want to move this file to be without the prefix. And we also have, oh yeah, even you can use less on the zip file. That's true too. Lots of ways to do it. Let's see, -o. I could have sworn I remember there was a way to curl files without doing all this manually. But yeah, this is kind of the real way, this is what it would really look like to get all this loaded up. Copy. And yeah, so over the next, wow, I just copied the word download, didn't I? Copy link address, thank you. Over the next episode, following weeks, probably we'll be kind of building this out piece by piece. Oh, I just realized before I run that. We have test images.csv, train images, which this thing is still chugging along nicely. We've received 17 out of 58 gigs, so that'll be an overnight job if I script out all the other ones too. And then train annotations. So if I move all the things that are training related, like training annotations, boundingbox.csv, and just put them all under train images. And I'm going to move the other training related thing, train images, boxable.csv. So that's the CSV of all of the images themselves and their links. So we're getting there. And then we want to create a folder for test images and move test annotations into test images and move test test images. So that's the images for the test dataset into test images folder. And then we're going to move validation annotation box into validation images. Getting there, almost done. Move validation images. Definitely just going to put them in the right folders going forward now. Okay, so the next one we wanted to do was the test dataset. So I'm going to cd into the test images folder. So now we have a much more manageable kind of file structure. We have our 2 CSV files. Now we're going to download our images themselves and let her rip. And it's just, yeah, again, it's so nice to be able to write to the same file system, right, ostensibly, without having the kinds of bottlenecks that you experience when you're writing to a real local file system. It's definitely one of those things that I think we don't think about much when you're doing cloud-based computing, because you don't need to. But as we can see here, if I go to disks in Compute Engine and I go and try to create a disk, and remember, these are still just spinning disks. There aren't even SSDs. You can see here, pay attention to how these numbers change as I increase the size of the disk. So right now it's a 0.5 terabyte. We have read sustained random operations of 375 and a sustained throughput of 60 megabytes per second read speed, which is like fine. But if I now up this to instead of 500 gigs, let's say I up it to 1 terabyte, I double it. Right now, our read speed and write speeds have basically doubled. We can write at 120 megabytes per second. Now, if I double it again to 2 terabytes in this disk, and we watch what happens to these numbers, it doubles again. And of course, it'll flatten off at some point, but is a illustration of the fact that it's because these disks aren't literally one giant disk. It's kind of all cobbled together, And so if we double it again to 4 terabytes, keep your eye on this sustained throughput numbers. We're now up to some range. So now we kind of see we're getting up to it, but you look at all of these operations, you can do a ton of operations per second, and this kind of is now a range. So we're getting to the upper end of things, right, in terms of what a single disk looks like. But you can see that even as I change between 3 and 4, the top end, right, is 360 now, and when I go to 4, the top end now becomes 400. Well, 480 and 400. If I go to 5, it's still kind of keeps pushing, especially the read speed keeps pushing, but the write speed appears to have capped off at 400. And you can see these numbers are still kind of going up. You can still do sustained random operations. So yeah, it's pretty crazy. Do we have any luck on this side? I mean, the good news is it seems like it works now. Who would have guessed that this would end up being a episode all about disk partitions? I might have to rename the episode. It's actually about how to mount disks, not so much about exploring this data set. We didn't even get to open that many or any images. I guess we should do that. Let's do that for one of these. Let's take a look at one of these validation images. What you can do is you can go to CSV. They got this preview button, so they have the links right here. I have not tried this link, so fair warning, I do not know what's about to show up on my screen when I press enter, and it's smoked salmon. Okay, that could have been worse. That could have been a lot worse. It's just smoked salmon. All good. And so at least we saw one of the images. We'll definitely explore it more. I seriously might change the name of this episode, and more importantly, I need to remember to complete this process. Otherwise, next time I reboot, it's going to be a bad time because I'm going to forget how to do any of this, and I'm going to have to remount the disk. So importantly, it's not enough to just say, connect this disk to a given virtual machine in this interface, but you also have to do it on the command line. Curl with the -o before the URL might work with a capital O. Thank you, Rajan. You have MVP this episode for sure. So yeah, I'll definitely make a note of that. We can try that on one of these CSV files. How about if I just take this and since I moved it all out, these two are both going. I'm gonna pause one of them. Which one should I pause? I guess it doesn't matter. I can resume them later. So I'm gonna pause this by hitting Control Z, and we're gonna try Rajan's idea here. Curl. Whoops. This should be on the same line. This is why not only do you want to prepare your stuff on a text editor beforehand, you gotta prepare it right. So this looks to work. So curl with a capital O will download your file without needing for you to specify it manually. And I managed to try a big file, but it did work. This was the 2.2 gigs. So we just downloaded 2.2 gigs in a whole 10 seconds. Not bad. And I'm going to remove it now because I don't need this one. But that changes everything in terms of these commands. Definitely will make sure I use that in the future. So huge thanks to Rajan for getting us sorted there. Meanwhile, let's wrap this up by let's see how they want us to do this. Create a backup of your current FS tab. So we're going to copy our file system tab. I want to look at it too because very curious. Okay, so that's what it looks like right now. I'm assuming that this is the one we added, this extended for value. Use the block ID command to find the UUID for the zonal persistent disk. This system generates this UUID when you format the disk. Use UUIDs to mount zonal persistent disks because they do not change when you move disks between systems. So if we recall, the device ID was the value that was after dev. So that's SDB in our case, and we can check that by running ls block. And so we see again it's SDB, so I'm going to run that. So block ID for our block is this. Is it the same as what was shown up here? It is not, so that's worth knowing. Actually, I'm just going to copy this whole line because this is good note to make. Right, so we did that. We got our block ID. Where block ID is that, UID is that, type is that. Open this file in the text editor and create an entry that includes the UID. Specify the no fail option to allow the system to boot even if the persistent disk is unavailable. Yeah, that's fair. UID value is our value, mount directory is our mount directory, and no fail option. Does it not? Oh yeah, they are giving it, so no fail right here. And then 02 means something. Optionally, you can create this with a single command. By locking it in and then running it all together. That's very clever. Let's see. All right, let's get our UUID value. Is that a string value or can I just type it directly? Well, we can see it here. We catted it. Okay, so there's no quotes. So an unquoted mount value, mount directly SDB. Roger says, I guess it's true when they say 80% of ML is about data preparation. Yeah. And then 80% of data preparation is about disk preparation, it looks like. So that's pretty funny. Let's see, it says UID. So this is the text we want to put in, let's see, vim, etc, fs, tab. Please allow me to open this file. It says read only. Okay, so this is one of those tricks where one of those rare times you need to run sudo vim so that it opens correctly. And it looks like what this command does, sudo t. I actually don't know the t command. That's interesting. I'm assuming it appends it. So let's append this line. Interesting. Okay, so what I'm seeing here is that it's the existing mount. Oops, I just realized you probably can't see all of that. Let me make it bigger. Okay, so the existing mounted version, right, mounted at root, that was our boot directory. So that's why there's just a slash and then a space. Then there's a file system and then defaults. And so we added things like discard and no fail and whatever 02 means, which is still a mystery to me. Cool. You can use the cat command to verify that your entries are correct. So hopefully ours looks something sort of like that. And that is the story there. Okay, let's write that out, close it up. And yeah, that is our story today, I guess, is we got to kind of try out using a VM to download our data. We learned a lot about persistent disks, partitioning them. And as Rajan said, it's quite true what they say. About 80%, maybe 90% of machine learning work is about data preparation. I mean, all we wanted to do today was gather our data set, and we got started, right? We were able to get underway. So thanks for watching. Thanks for joining me today. Let me know if you have questions, comments down below or in the live chat, and what topics you want to see covered in future episodes. I really look forward to the next episode. Hopefully we will get further along here now that we have the right disk size mounted to the right virtual machine and we've got the right download instructions. While we're off the air, I'm probably going to kick off the rest of these downloads, and then we'll be able to actually get in there next time and do some cool stuff. So until then, I've got this little outro prepared for you. Enjoy.